This is an application problem that can be solved using differential equations. The first part of the problem asks for finding the maximum height above the ground of an object of mass of 18 kilograms that is shot upward with initial velocity of 370 meters per second. We have to assume that the force in newtons to the air resistance is 1/10 times v, velocity. So the object will attain its maximum height when the derivative of the distance is equal to 0. And that is when the velocity is equal to actually 0, because the derivative of the distance is equal to the velocity. So we have to find when the derivative, which is the same as the velocity, is equal to 0. In the same way, or in the second question, we have to find the maximum height it will attain. Well, we have to, in the first problem, find when. When means what time. At what time the velocity will be equal to 0. And then the second part, the maximum height will occur at that specific time. So we need to find the value of, or the expression for, the distance, and then evaluate it at the value of t we found in the first part of the problem. So we need to set up a differential equation and an initial condition so that we can solve this initial value problem. So let's say that y of t is the distance from the object to the ground and this is going to be a function of t. And then let's set v of t, velocity of the object. Therefore, we know that the relationship between these two quantities is that velocity is the first derivative of the distance. So the object moves in the upward direction. So we can assume that at t equals 0, then the object has traveled 0 meters. And then the velocity when the motion starts, as indicated in the problem, is 370 meters per second. So these are the initial conditions for our problem. On this object, two forces are acting. In the system formed by the object, two forces are acting. The gravity force. Which is f of g equals to minus m times g. M is the mass of the object, and g is the acceleration due to gravity, and is negative because the object is shot upward. And also, in addition of the gravity force, or force of gravity, we have the air resistance force, or F sub R equals to -1/10 V, as it is opposite to the motion, and that's given in the problem. This is given in the problem. So, applying the second Newton law, the second law of motion, second law of motion, we have that F equals to F of G plus F of R, or F sub R. The force due to gravity plus the force due to the air, the resistance of the air. So there is a balance of the forces. We know that force is mass times acceleration, and then Fg is negative mg minus 1/10 v. But recall A is the second derivative of the distance and the first derivative of velocity. So we can write A as dv dt. So we have m times dv dt equals to -m times g minus 1/10 v. So now we can divide everything by m in order to come up with a differential equation that is familiar to us. So we divide everything by m, and then we have dv dt equals to -g minus 1/10 m v. And then recall m, according to the direction of the problem, m is 18 kilograms. M is 18 kilograms. M is equal to 18 kilograms. So we have dv dt equals to -g minus 1/180 v. Then now we can rewrite it as dv dt plus 180 v equals to -g. And then this equation is linear. That's a linear equation. This equation is linear. It's a linear equation, that first order linear equation, differential equation, that can be solved using an integrating factor. So we can find now the integrating factor so that we can solve this differential equation. Integrating factor of this linear equation, it is u of t. Recall now our independent variable is t, equals to e integral of p of t dt. Then p of t is that term multiplying v. So in this case, p of t is equal to 1/80, and q of t is equal to -g. So we have e to the integral of 1 over 80 dt, and then this integral is going to produce an integrating factor of e to 1 over 80 t, or simply e to t over 180. So that is our integrating factor. So it's time now to multiply our linear equation dv dt. This is our linear equation, and then we now multiply by that integrating factor we found, which is e to the t divided by 180, and then that's going to produce e to t over 180 dv dt plus 1 over 180 e to t over 180 v equals to negative g e to t over 180. So recall, in this differential equation, the left side of the equation is going to be simply the application of the product rule of the integrating factor, which is e to t 180 times the dependent variable, which is in this case v. And then the right is e to t to 180. Then now, as expected, we can pass two integrals. We now integrate on both sides. And then we simply have e to t over 180 times v equals to negative g e to t over 180 divided by 1 over 180. Therefore, our integral can be written like this. Would be negative 180 g e to plus c. Don't forget the c, plus negative 180 g e to t over 180 plus c. And then we can now divide everything by the integrating factor. You're trying to isolate v. So v is equal to negative 180 times g. Then when we divide by e to t over 180, that term is going to cancel. So we have simply plus c times e to negative t over 180. So that is our expression for the velocity depending on t. And then we can replace g by its value, 9.81 meters per second squares. So that would be negative 1765.8 plus c e to negative t over 180. And then now we can apply the first condition we come up with at the beginning of the problem, setting up the conditions, velocity at 0 is equal to 370. So keeping that in mind, so we have the 370 is equal to negative 1, 1765.8 plus c times e to 0, right? And that is 1, e to 0. So c is equal to 2135.8. So that's going to be the value of the constant c, and then we can write the expression of the velocity as v of t equals to negative equals to negative 1765.8 plus 2135.8 e to negative t over 180. So recall, now in the first part of the problem, we had to find when the object attains its maximum height. So it attains its maximum height, the maximum height of the object occurs when v of t is equal to 0. So we have to set up this equation equal to 0. We can set up this equation 765.8 plus 2135.8 e to negative t over 180 equal to 0. So here we are solving for t. So we have an exponential equation. So we have an exponential equation that once we subtract by 1765.8, we have 2135.8 times the exponential. So we have we move the constant to the other side, then divide by the coefficient of the exponential, and then we have simply e2 negative t over 180 equals to 1765.8 over 2135.8. And then we're going to apply ln on both sides in order to isolate t, which is the purpose of this part of the problem. Apply ln on both sides. So the ln and the exponential, they cancel. So we have simply on the left negative t over 180 equals to ln of 1765.8 divided by 2135.8. And then once we multiply by negative 1, the fraction on inside the log is going to switch, because the negative can be written as an exponent of the inside of the log, the argument of the log. So the nt is equal to 180 ln of 2135.8 over 1765.8. So that's the value of t. And then once we compute the ln and we multiply by 180, once we enter these numbers in a calculator and then we multiply by 180, we find the ln of 2135.8, 65.8, and we multiply by 180, we get 34.24 seconds. So that's the answer to the first part. When? Well, when the time, when t is equal to 24.24 seconds once the object started moving. Now, to find the maximum height, now it's time to find the maximum height, which is the second part of the problem. How to find the maximum height? Well, to find the maximum height, we need to find an expression for the distance and then replace the value of the time we found in that expression we're going to get soon. So y of t is going to be the integral from the initial time, which is 0 to sometimes t, and then it's actually the integral of the velocity. Since we have an expression for velocity, we are in condition to find the integral. So it's going to be the integral or the integral from 0 to t of negative 1765.8 plus 2135.8 e to negative t over 180 dt. So that is our velocity. That is the expression of the velocity we found. So we compute this integral. It's negative 1765.8 times t is the integral of a number times the integral of a number is the number times the independent variable. In this case is t. Then we have the exponential is the same exponential, the same exact exponential divided by negative 1 over 80. Negative 1 over 180, I mean. So we're going to get from 0 to t. So we're going to obtain negative 1765.8 t plus, so we multiply, so we have plus minus, actually minus 180, because we flip the fraction, times 2135.8 times e to negative t to 180, t over 180 from 0 to t. So that's the result of this definite integral. So it is time now to replace the limits of integration. So we replace the first limit of integrations. The first limit of integration, we're going to obtain negative 1765.8 t minus, we can multiply 180 by the constant in the front, so that is 384,444 times the exponential minus the evaluation at 0. So the evaluation at 0 for the first number is going to produce 0, because 1765.8 times 0 is 0. And then the second evaluation, the evaluation of in the second term at 0 is going to produce plus 384,444 times the exponential, and then to rewrite the expression, we can write it as negative 1765.8 t. We can take common factor the coefficient, which is 384,444, and the exponential, and then inside a parenthesis we're going to have 1 minus e to negative t over 180. And what left t is actually 2. So this is the expression for y of t, distance. So when the object attains its maximum height, we found that already. That happened at 34.24. And actually, what is the maximum height? Now we're finding the maximum height. Well, the maximum height is when we evaluate this expression of the distance at exactly what time we found. And that would be negative 1765.8 times 34, 24, plus 384,444 e to negative 34.24 divided by 180 times here we don't have an exponential here, so here the exponential is not common factor. So we have just 384,444, which is the common factor. I'm going to now shade it in blue. Okay, so this exponential shouldn't be there. So we just take common factor, the coefficient, because remember when we replace 0 in the exponential is going to be 1, because e to 0 is 1. So we have 384,444 times 1 minus e to negative 3484 divided by 180. And then once we do that calculation, we're going to obtain 6,134.17 meters. And this concludes the problem.